Hi guys, so we're moving on to our next section, getting away from inequalities and absolute values, and we're moving on to functions in their graph. So you guys should have this handout in front of you. So let's get started with them. First thing, a relation is a mapping of input values with output values. Okay, we call the domain our set of input values, and our range is the set of output values. The relation itself is a function if there is exactly one output for each input value. So we can say it's a function if there's only one output for each input value. It's not a function if one input has more than one output value. And the relations can be written as an ordered pair, right? We know an ordered pair is x comma y. Okay, so basically we're saying if we want to tell if a relation is going to be a function, there can only ever be one y value for an x value. So every x should have exactly one y. So if I look at my first example, my input is my x, my output is my y, right? For -3 on my x, there's one output. However, for 1, which is an input value, there are two outputs. That can't happen. For every x, there can only be one y value. So this relation here is not a function. If we look at our second example here, my input's my x, my output's my y, right? For my first input, there's one output. For this input, there's one output. For this input, there's one output, and this input, there's one output. So even though 3 and 4 have the same output, each x has exactly one y as an output. So each input has exactly one output. So this would be an example of a function. Okay, we can also, if we don't have like this table of values here, we can also test to see if a relation is a function by using the vertical line test. So a relation is a function if and only if no vertical line intersects the graph of a relation at more than one point. Okay, so say I have a line like this, right? If I were to draw a vertical line and use my vertical line test, right? My blue lines are my vertical line test. No matter where I drop that line on my graph, their vertical line is never going to intersect at more than one point. No matter where I drop it along this line, it's never going to intersect at more than one point. An example of a graph that is not a function is, say I have something like this, right? We're not used to seeing graphs that look like that, but that is still considered a relation. However, if I use my vertical line test, when I drop that vertical line, we see that it intersects my relation at two different points, right? Before it only intersected at one. Now it's intersecting at two different points. That can't happen. So the first example would be a function, and that passes my vertical line test. The second example is not a function because it does not pass our vertical line test. So if we need to graph relations on our own, right? If I have an equation that has x and y, the first thing I need to do is construct a table of values. And we construct that table of values by choosing values for x. So we can pick any number that we want to for x. We take those values, we plug them into our equation, and when I plug in those x values, I'll be able to get my y values back, right? I'll be able to solve for my y values. Once I have my table of values all filled in, I'm going to take those values and I'm going to graph them as points, right? So when I plugged in an x, I got a y value. That's going to be 1 point. And once I graph all my points, I can draw my line that connects my points. So if you skip to the next page here, we want to graph the function y equals 2x plus 1. So first step, I set up my table of values. Okay. On this table of values, we said it doesn't matter what you choose for x, you get to pick whatever number you want. So that with that in mind, we always want to choose the easiest numbers we can think of, right? In this case, I always end up choosing -1, 0, and 1. Okay. When I look, I'm going to have to multiply the x by this 2. So plugging in and multiplying 2 times -1 times 0 or 1, those seem fairly simple. So that was step 1. We make our table of values here. We pick our x values. Now we have to plug each of those x values into this equation for x to figure out what our y value is at that point. So I'm going to start with -1. I say y equals 2 times -1 plus 1. You'll see I replaced my x with -1. We know 2 times -1 is -2. -2 plus 1 will give me -1. So when I plug in -1 for x, I get -1 for my y value. Then I plug in 0. I say 2 times 0 plus 1. We know 2 times 0 is 0. 0 plus 1 will give me 1 for my next y value. And then for the last one, we plug in 1. So I say y equals 2 times 1 plus 1, right? 2 times 1 is 2. 2 plus 1 is going to give us 3. So my last y value is 3. Step 2, once we filled out our table, step 2 was to take our table of values and then graph them. So we had said when we plugged in the x as -1, our y value is -1. So the first point I'm going to plot is -1, -1 on my graph. We also plugged 0 in for x and got 1 for y. So the next point I plot is 0, 1. And when we plugged in 1 for x, we got 3 for y. So the next point would be 1, 3. And from there, step 3 was once we plot those points, we just get to connect our line. Okay, so you use your equation. You pick easy numbers to plug in for x, plug all of those in individually, get your y values, and then plot them. If you look at this next example, we have the equation y equals 1/3 x minus 2. So step 1, we have to make our table of values. But something we want to keep in mind is when I'm picking points or I'm picking numbers to plug in for x, I'm going to have to multiply it now by a fraction. So the easiest thing we can do is try to pick numbers that are going to help us cancel out our fraction altogether. So instead of picking -1, 0, and 1, right, if I multiplied this by 1/3 by 1 or -1, that wouldn't cancel out my fraction. I want to pick -3, 0, and 3. And if you notice, that's the positive and the negative of the denominator here, right? And the reason why we pick -3, 0, and 3 is when I take 1/3 and I multiply it by -3, right? I can say -3 is the same as saying -3 over 1, right? So when we go to multiply this together, 1 times -3 is -3. 3 times 1 is 3, right? -3 divided by 3, that can simplify to -1. So at the end, when I multiplied these fractions together, it really canceled my fractions out and gave me -1. So now I can take -1 minus 2 to give me -3 for my y value. We don't have to necessarily worry too much when I have 0 because we should remember anything times 0 is 0. So even 1/3 times 0 will give me 0. 0 minus 2 will give me -2 for my next y value. But again, when we now plug in 3 or 3 over 1, when we multiply these, I get 3 over 3 minus 2, right? 1 times 3 is 3. 3 times 1 is 3. So if I simplify 3 over 3, that's going to give me 1 minus 2 to give me negative 1 as our next y value. Okay, so this one was a little bit different because when we were plugging in values for x, we had to multiply it by that fraction. And that fraction's not going to go away unless I was working with numbers that were similar to the denominator here. So negative 3, 0, and 3. So that was step 1. We made our table. We filled out our table by plugging in all the values for x. So then we go and graph them. So our first point would be negative 3, negative 3. Our next point from our table would be 0, negative 2. And our last point, we would graph 3, negative 1. Okay, that was step 2. And now step 3, we can connect all of those points there. Okay, so there's a difference, right? There's a difference between when I have an easy number like 2 that I have to multiply by x by, or if I had to multiply by a fraction. On this next example, when it says graph the function y equals 1/2 x plus 3, again, because we're going to take x and multiply it by a fraction, I want to choose x values that are going to help me cancel this fraction. So that would be multiples of the denominator. I could do negative 2, 0, and 2. So then I would take each of these values, plug them in for x. I'd get y equals 1/2 times negative 2 plus 3. Again, we can say negative 2 is the same as negative 2 over 1. So 1 times negative 2, 2 times 1, right? Negative 2 over 2 will simplify to negative 1. Negative 1 plus 3 will give me 2. Then we plug in 0. So 1/2 times 0 plus 3, right? Anything times 0 is 0. So 0 plus 3 is equal to 3. And then lastly, I plug in 2. So 1/2 times 2, or 2 over 1, plus 3. We can simplify 1 times 2 is 2. 2 times 1 is 2. And then we can add the 3, right? So 2 over 2 reduces to 1. 1 plus 3 will give us 4 for that last y value. Okay, so we can take our table now. It's going to jump to the next one. We can take our table. The first point is negative 2, 2. The next point is 0, 3. And then the last point is 2, 4. Okay, so we can graph these now. Negative 2, 2, 0, 3, and 2, 4. And then we can graph them with the line. Okay, so I want you guys to take these examples. You guys can rewind and you can go over them again if you still need to watch how we're doing it, but take these examples, use that information, and I want you guys to pause the video and try these 2 examples on your own, okay, and actually try them. Don't just skip and wait for the answer, right? But I want you guys to actually try these because I am going to assign you some problems for you to do. So pause the video now and try these next 2 problems on your own. Okay, so hopefully you guys paused it. On this example here, we have y equals x minus 2, so we set up our table. Because if we look at our example, because we're taking x and we don't really have to multiply it by anything, it's already by itself, this is an example where we could pick negative 1, 0, and 1, right? The only time we shouldn't pick these is if I'm working with a fraction. But because there's no fraction here, we can just plug in negative 1, 0, and 1. So if I plug this in, we'd have y equals negative 1 minus 2. That gives me negative 3. We'd have y equals 0 minus 2. That gives me negative 2. And we'd have y equals 1 minus 2. That's going to give me negative 1. So the first point we plot is negative 1, negative 3. The next point is 0, negative 2, and then the last point is 1, negative 1. And our graph should look like this. Okay, the last example here, I'm going to set up my table. Because my x value I'm going to have to multiply by this fraction, this is an example where I want to work with something like the denominator. So in this case, I would pick -2, 0, and 2 as my numbers I'll plug in for x. So I would plug in y equals -1/2 times -2 plus 5. Right? -2 we can say is -2/1. So negative times a negative becomes positive. 1 times 2, or -1 times -2, will give me +2. 2 times 1 is 2, so 2/2 plus 5. We know 2/2 is 1. 1 plus 5 will give me 6. Plug in 0. -1/2 times 0 plus 5. -1/2 times 0, or anything times 0, is 0. 0 plus 5 gives me 5. And my last one, I say -1/2 times 2 plus 5. We would say that's 2/1. So -1 times 2 is -2. 2 times 1 is 2 plus 5, right? So then -2/2 reduces to -1. -1 plus 5 gives me +4. So on this one, -2, 6 is our first point. 0, 5 is the next point, and then 2, 4 is our last point. And those we can connect. Okay, so on Google Classroom, you guys should see your book pages here posted. Make sure you are working on this. You are obviously going to need to graph all of these equations. So the graph paper is over towards the door on that little table. You'll see a tray that has a bunch of different graphs printed out. Okay, so I mean, this video is here for you guys to use as a resource. You can rewind it, you can keep going over the examples if you need some more time with it, but work on these bookwork problems. If you don't finish in class today, it will be due by the beginning of next class, so you'll have to finish it for homework.